That's right, finally I have a microphone. Previously I was using the microphones built in on the MacBook, and they sound really, really bad. Hopefully this video is going to sound a lot better. So we've been sent this question by a student, and we're going to show how to work it out. If you want to send in your questions, details are in the description, and if you're interested in private tuition, visit our website, skittles.school, to book a free demo lesson. Okay, let's take a look at this question then. So here's the question. We've got a triangle, ABC, which are all points on the circumference of a circle. And the center of that circle is point O. We've also got a tangent DAE, and it's a tangent at point A. So it's touching the circle at A. We've also been given some angles. Angle BAE is 56 degrees, and angle CBO is 35 degrees. And it's asking us to work out the size of angle CAO. So angle CAO is this angle here. That's the one that we're trying to work out. Okay, let's take a look at this. And first of all, I'm going to get rid of the words because all the information that we need is on the diagram. It's going to give me a little bit more space to write. So here's the same diagram, and there's the angle that we're trying to work out. So let's make a start. I'm going to start by identifying that this is the alternate segment theorem. So the angle between a tangent and a chord is equal to the alternate angle in the segment. So what does that mean? Well, that means that the angle between the tangent and the chord, so this tangent here, and this chord here, form an angle, which we've been given, and that's angle 56 degrees. And the alternate angle, so the opposite angle in the segment, is the same. So the opposite angle in the triangle is the same as that. So this angle here is the same. That's also 56 degrees. And there is a whole mathematical proof to that, but the question is not asking for that. So we can say angle ACB is equal to 56 degrees, and that's because of the alternate segment theorem. So I'm going to write that down as part of my answer. Alternate segment theorem. Okay, so we've worked that out. Now I'm going to show that this here is a radius. This is also a radius. And we know that the radii of the circle are always the same because it's the distance from the middle of the circle to the outside of the circle. I'm going to put another radius on the circle. So here's another radius from the middle to a point on the circumference. Here's another radius. So that's also going to be the same. It's also going to be equal to these lines. We notice that it forms another triangle. So here's another triangle. This blue triangle here. And we can tell that this is an isosceles triangle because two sides are the same. They're both radii. So we know that with isosceles triangles, the base angles are the same. So the base angles are the angles at the ends of the two radii. So this angle here also has to be 35 degrees because it's the same as the other 35. So we can say that angle BCO is also equal to 35 degrees. We can give the reason, and it's the base angle on the isosceles triangle. Okay, so now we've got that. Now what we've done is we've split the 56 degrees into two angles. One of them's 35, and that helps us work out this side of it. So this side of the angle is 56 subtract 35. So we can say that angle ACO is equal to 56 degrees subtract the 35 degrees. And that's 21 degrees. Okay, we've got 21 degrees. And if we notice, there is another triangle there. This green triangle, where one of the angles is the 21 degrees. We can see that two of the sides are again radii of the circle. Therefore, it's an isosceles triangle. And the base angles on the isosceles triangle have to be the same. So we now know that this one also has to be 21 degrees, and that's the angle that we're trying to work out. So angle CAO is equal to 21 degrees. And we're going to give the reason, because it's also a base angle on an isosceles triangle. And that's the answer. So the key skills you need to revise for a question like this are circle theorems and angles inside a triangle. Now, I offer one-to-one tutoring. If that's something for you, visit the website skittles.school to book a free demo, or just keep sending in your questions. I'm trying to make one of these videos every single day. If you found this video useful, give us a thumbs up and a like, and also subscribe to stay up to date with future videos. So until tomorrow, thanks for watching.